Well, thank you everyone for joining me virtually today. I'm Stefanie, and I'd like to introduce you in the next 25 minutes how we at ESA are starting our open source software project journey, to make the long title short, and how we are creating open collaboration and are building a new community around one of our novel Earth Explorer satellites, the Biomass mission. So today I will introduce you to our novel pilot open source solutions, the multi-mission analysis and algorithm platform MAAP that is connecting Earth observation data, processing resources, and a community online in the web, and the Biomass product algorithm laboratory, which is basically a pilot project for ESA exposing an official processing algorithm to every user, making this algorithm fully transparent for the first time. So to share a little bit of content today, first I would like to introduce you to our 7th Earth Explorer mission, Biomass. Then I will basically, that Biomass mission is going to create the data that will be processed by BioPal as an official operational processor. These data products processed will be hosted on the MAAP platform together with other resources and tools. And all of this hopefully will lead to faster scientific discovery and a success of the Biomass mission. So let's get started on Biomass. Biomass is ESA's 7th Earth Explorer mission, scheduled for launch now in February 2023. For everyone, Earth Explorers are smaller research missions dedicated to specific aspects of our Earth's environment, whilst demonstrating new technologies in space. So these missions address critical and specific issues raised by the science community, really while demonstrating the latest observing techniques. And if these smaller missions are successful, and if these new technologies are successful, they may be continued into a larger mission, or parts of the technology will be implemented in larger missions, for example, within the ESA Sentinels program and a more operational satellite. So Biomass's primary scientific objective is to study the Earth's carbon cycle by measuring and quantifying global forest structure, for example, forest height, or forest disturbance, or above ground biomass. And in the case of Biomass, we have an operational period for 5 years, a planned operational period. So our Earth Explorers are really designed to exploring the unknown, both in terms of research objectives as well as technologies and data processing. And Biomass is really the first time that ESA measures above ground biomass from space. Biomass also has the first ESA P-band SAR sensor in space. And it's the first time that full polarimetric SAR and interferometry are ESA mission objectives. Of course, these new sensors also lead to new data sets. So in the scope of the Biomass mission, we will provide biophysical parameters, forest height, forest disturbance, and above ground biomass. And at ESA, we describe different data sets we provide according to the level of processing of raw satellite data that happens from level 0, level 1, which is more raw data, to level 2 and 3, which are more finalized data products. So what is important for today to know is that we use something called an operational biomass processor to transform these level 0, level 1 data products into level 2 and level 3 data products. Here in case of Biomass, level 2 is forest height, deforestation, and above ground biomass. And level 3 will be global maps of these measured forest parameters. So these operational processes are essentially a set of algorithms, can be Python code or can be C code. And typically these operational processes are to date only open to a handful of individuals, and they're not open to the public, which will change with BioPal. So to summarize this section, Biomass is a true Earth explorer with a lot of unknowns, but also exciting science for global biomass mapping and beyond to happen. So the novelty of the mission and its instrument in combination with a relatively short period of data collection of 5 years poses several challenges to scientific users as well as our agency. And the question for ESA is really, how do we make the future of Earth observation users better with biomass? Because we aim to support researchers in the best possible way to generate the best possible data products, and also to generate scientific discoveries as fast as possible to provide scientific support, for example, to policymakers or also for international treaties and agreements. So on the side of user challenges, we have what we describe as more classical big data challenges, the problem that a satellite produces vast amounts of data, and we can only currently give limited access to this data. Because users need storage capacities, they also need computing resources. So we also, because of biomass being so new, have currently no standardized tools, Python packages, to actually process and analyze the data we provide. And we also only have a very small scientific community pre-launch of the satellite. On our agency side, we have the challenges that we want to distribute the data to the user and establish these standardized tools. And also that we need to update the prototype processor that generates currently the L2 data product as soon as the mission is launched. So algorithm development is very challenging pre-launch because often researchers that work on these algorithms only have simulated data they can use to develop, calibrate, and validate algorithms. And we are expecting the opportunity for enhancements once the satellite is launched. And we can access basically the real deal satellite data and receive feedback from the user community. So also here, to summarize, we have currently in the EU Earth observation user space identified the issues of data access, of community building pre-launch, and also of algorithm development and joint algorithm development of these operational processors, basically to address scientific community needs. And as a solution to these previously suggested challenges, we basically propose BioPal to enhance the biomass processor collaboratively once biomass is launched, and the map as a platform that really brings user activity closer to the data instead of trying to distribute the data to users. So the solutions we propose allows for easy data access and sharing in the cloud and joint algorithm development. Also, it enables interoperability of data, code, and algorithms, and supports transparency in research and development and data product validation. So the goal here is really to break down the wall between science and operations and facilitate faster scientific discovery. And also by basically evolving processing algorithms together with the data in the same environment, which hopefully will allow for a faster, stable algorithm for future R&D missions like Biomass on a user cooperative approach. And it's also very important to us to basically involve people outside of the core science team to contribute to making data products ESA provides better. Okay, so getting into detail, MAAP. MAAP is a virtual and open collaborative working environment that is accessible via a web platform. If you scan the QR code here, it will directly lead you to our landing page. And in MAAP, ESA is bringing together Earth observation software, collaborative tools, Python packages, with computing resources and hosted processing on Orange Cloud, and a data center that contains Earth observation data and non-Earth observation data. So that really connects the Biomass mission data to airborne data and in situ data, or potentially also your own data if you want to upload something. MAAP is actually a federation of two platforms, the ESA-MAAP and the NASA-MAAP, with a common user interface. Both of these platforms are currently in the pilot phase, and we're already seeing that they merge more and more. On the user side, that basically means that MAAP does not only expose Biomass satellite data, but also JEDI data and NISAR data, which are other very important projects in quantifying above ground biomass. So what are user functionalities that MAAP provides? If you, or when you access MAAP, you can basically log on and directly explore the data that MAAP provides in our catalog. You can search for data in specific areas, or search for specific times, or search for specific data sets globally. And you have the opportunity to quickly visualize your data results without even having to touch a line of code for now. Once you're happy with the data you chose, you can choose your working environment, which is here, for example, Jupyter Lab, or also Eclipse J. So then if you have your data and you want to explore it a bit more, you can develop your own code. You can try and choose from standardized tools and code that's already provided by the MAAP. But in case you detect that what you want to do hasn't been done before, you can basically write your own source code. And you can provide also a pull request, an issue, or something else to us to improve either BioPal or the general data analysis workflow. So MAAP is connected to a specific Git, but of course you can also manage your normal development workflow and connect MAAP to GitLab or GitHub outside of MAAP. You can then, once you're happy with your workflow, run an analysis, for example, in our orchestrator called COPA. And after you achieved your results, you can share and collaborate these results and also ask questions on the MAAP user forums, the MAAP communities. You can check out other projects in the MAAP GitLab, or you can also contribute open issues, share documentation on affiliated projects like Plant or BioPal, which are GitHub and GitLab projects. Okay, so this is really the first time that such a platform is developed for experimental missions. And for ESA, it means a bit of a paradigm shift from delivering data to the user to moving user activities closer to the data. MAAP is developed in 2 phases. We have a pilot phase where only the core team has access to the platform, and a full phase where everyone can access the platform. And we're currently transitioning from the pilot phase of the MAAP to the full phase. The full phase will likely start off with everyone being able to access the platform in March 2021. But we're always looking for interested parties to test or to contribute. So if you're interested, then please feel free to reach out. Our contacts are at the end of the presentation. Okay, so coming from MAAP to BioPal. BioPal is testing for us at ESA if an open source project approach works for an operational processor. And it also is a lead example of how algorithms can be created, developed, and ultimately accessed and integrated into the MAAP. So the Biomass Product Algorithm Laboratory is an open source software project that's currently hosted on GitHub. Our code is written in Python, and of course, we also use Git and Jupyter. The current source code is the L2 prototype processor, and we're working on basically validation and analysis tools that come with this prototype processor. We are also really promoting the open source best practices. So we have implemented governance structures and contribution guidelines. We're working on ways of packaging and distributing this source code beyond MAAP, for example, with Docker or pip. We're working on continuous integration and testing so that if users want to contribute, they can basically, it can be checked what code they are creating. We're also working on enhancing our documentation. And it's quite important to us to not only support processing in the command line, but also provide support for interactive coding environments like Jupyter. So the goal of Biomass is really also to provide a lead example of how such a project or such algorithms that ultimately work with biomass data could be set up and could be integrated into the MAAP. So to bring it all together, how is the product algorithm laboratory connected to the MAAP? So currently we're also in the pilot phase of initial algorithm definition and the first algorithm implementation, which is again pre-launch of Biomass and of the MAAP platform. And once the Biomass mission is launched, we are hoping on algorithm improvement by MAAP users through exposing the source code in the official, together with the data in this official platform. So users can modify L2 and L3 processing code. They can generate their own new data sets with their own modifications, but they can also test these modifications on official testing data sets that are used for quality assessment of these official operational processors. So once they're happy with their modifications, they can, for example, provide a pull request to BioPal from the MAAP environment. ESA can check and approve these pull requests. And together we are really enhancing the data products that ESA provides. So integrating MAAP and BioPal enhances these processing algorithms. And on ESA side, it will allow us to faster arrive at a stable algorithm for R&D missions like Biomass. And it's also really, really very important to us that people outside of the general core science teams can contribute to that product improvement cycle. Okay, so that's where BioPal is hosted on GitHub. It's currently still private. We're going to launch it on October 16th as a, again, saying as a pilot project. you can check it out in github.com under biopal if you'd like to. Okay, so to conclude, biopal is really a proof of concept to arrive faster at stable algorithm development for these very exploratory Earth Explorer missions through collaborative development together with the users. And MAAP provides the connection between the mission data, these algorithms and other software and results, and hopefully really enhances a reproducibility of scientific research and breaks the wall between science and operation. If you're interested in any of these projects, please feel free to reach out. We are reachable via the official biopal ESA.in email address or our private work email addresses. And with that, I say thank you, and I'm happy to answer questions if there are any.
Thank you very much, Stefanie. I see there are at the moment no questions in the Q&A and no questions in the chat. I think people are getting tired. It's getting late already. It was a long day. So I do have a question. So everything you do is open source, or how do you do that?
Yeah, so we basically have this pilot phase where we are like, I'd say I call it partly open source. Specifically in biopal, we're aiming to open up the core, the first implementation or the first design of the prototype processor as soon as possible, so that people can really potentially give feedback, for example, on documentation and if they understand what is happening. But with the full phase that comes with mission launch or a year before mission launch, everything will be completely open. And it's quite important to ESA as well. So if you want to contribute, for example, with another software tool, you can only register as an official algorithm on the platform if you have a permissive license.
Okay, that's interesting. So are there any more questions? You can use the GeoTrack chat. It seems there are no questions at the moment, but I'm sure it will be a little while in the chat if someone comes up. Ah, no, wait, there is just a question popped up. So Michael Turner asks, can you see this open system being extended to the other ESA missions datasets if it's successful?
Yeah, so the idea of the MAAP and also biopal as an open source project is really to test this open source format for ESA and for new Earth Explorer missions. So it's basically a way of innovating the ground segment that deals with data distribution and quality. I think there are already parallel efforts for the Sentinels, but for us, it's more on the side of the Earth Explorers. So the whole goal of this activity is to hopefully have a format for ESA that's operational for new missions. So the short answer is yes.
Great. So I see there are no more questions at the moment. So thank you very much again. And we will have the lightning talks next. We will start the lightning talks. We're a little bit late at 4:30, and let's continue there. Lightning talks will be in this channel, in this room. So you can stay here, and the room 2 will be closed during the lightning talks. Okay, thank you very much, and see you soon at the lightning talks.